Okay, now I'm going to solve a problem from section 1 just using the computer and using our data analysis tab. So I've made up a problem here that just shows these are two of my sons and they're like 1st and 5th grade. And I just used some numbers possibly from the number of points they scored in their basketball games this year. Now, they're not all real numbers, but they're pretty close to probably on average what they scored. So I have all of my sample data here in the computer, and also it is known, assume that it is known, that the population standard deviation for Chase is 1.1 points and the population standard deviation for Blake is 0.9. Okay, again, I don't normally think you would know the population standard deviation, but we're going to work it that way. And so then our hypothesis is that the average of Chase's scores minus the average of Blake's scores would equal to 0, and if that's true, then there's no difference between the number of points they scored. If the average of Chase's minus the average of Blake's does not equal 0, then there is a significant difference between the two amount of points that they scored. So let's go to the computer and show you how to do this. So we're going to go to data analysis up here at the top. Sorry, hope you can see that. And then down here you can see, if you scroll down to the bottom, you can see there's all these different options for t-test, 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 and z-test. So z-test, the very last one, is the one we're going to use for 2 samples finding their means. So that's what we have here. So we're going to click on that, and you can see at ASCII for variable range 1, and variable range is going to be 1 is going to be Chase. So I'm going to highlight all of Chase's points he scored in the game. And then variable range 2 is going to be Blake's, so I'm going to go up here and highlight all of them times he scored in a game. Sorry, this is kind of awkward to work. This right here in front of me. So I'm going to highlight his, and you can also see they don't have to be equal in number. I did that on purpose just so you could see you could have different sample sizes. So the sample size of group 1 was 15, the sample size of group 2 was 16. And then my hypothesized difference is 0. I'm just trying to prove if there's any difference at all. And then this is where I put in my my variance of each group. So my variance of group 1 and my variance of group 2. And let me find that real quick because I didn't. Okay, so when I take my standard deviation of 1.1 and square that, because you want to use your variance, I'm going to get 1.21. And my variance of group 2, which my standard deviation was 0.9, so my variance would be 0.81. Okay, I didn't highlight the words Chase and Blake, so I'm not using my labels, and we're using 5% level of significance. And then I'm going to click OK, and I'm going to get this output right here. Let me zoom it in here so you guys can see it a lot better. If I can get my computer to cooperate. Okay, and you can see here that this tells us that the average scores by Chase was 5.2 right here, and the average scores of Blake was 4.75, and then we knew the variance of the two, oops, come back, okay, we knew the variance of the two groups, and there's our sample size. Now we're using a two-tail test because we said equal to. If we had tried to find if one was greater than or equal to or less than or equal to, we would pick one of these one-tail tests. But we're going to find, here's our p-value right here for a two-tail test. That would have been the p-value for a one-tail test. Now because that p-value there is greater than 0.05, then we're going to go ahead and accept our null hypothesis, which is that there is no difference between the two. Now obviously there's a difference. 5.2 and 4.75 are different, but it's not a significant difference. It's not enough difference to actually make the statement or the hypothesis that they are different. So we proved in this that the two sons basically scored the same number of points in the games for the season.